Okay, in this video, let me explain about Werner's coordination theory. Alfred Werner was regarded as father of coordination compound or father of coordination chemistry. He started the study of this coordination compounds. Now, in his theory, he forwarded some postulates explaining about the nature of the complex nature of the property of the central metal in a complex. So in this video, let me explain the postulate. In the first postulate, in a complex, the central metal has two types of valencies. Here valency means, you can say, interaction. Okay, so let me change the color of the now two types of interaction, or two types of, you can say, valency. Okay, or you can say two types of bonding. Okay, so the valencies are called primary and the secondary valencies. In the following postulates, details about primary and secondary valencies are given. So in the first postulate, two types of valencies of the central metal is possible in a complex, and the first one is primary and second one is secondary valency. So I'm writing primary as 1 degree here. In the second postulate, the primary valencies are ionizable and are satisfied by negatively charged ions, which means when the complex containing a primary valency is dissolved in water, the primary valencies will be ionized. And the important point here is the primary valencies are satisfied by the negatively charged ions, means the primary valencies are the anions. Okay, so let me go to the third postulate, and then let me explain about this two postulate. In the third postulate, this is the third postulate, which is about the secondary valency. Here it is written as the secondary valencies are non-ionizable and are satisfied by negatively charged ions as well as neutral molecule. Okay, here one example is given. The complex is of cobalt is a central metal here. Cobalt is the central metal, and the ammonia and the Cl are secondary valencies here, and bromine is the primary valency. Okay, when it is dissolved in water, this ammonia and what chlorine, they are secondary valency, and bromine is the primary valency here. When it is dissolved in water, ionizable or non-ionizable means when it is dissolved in water, the secondary valency, which are satisfied by ammonia and the Cl here, they do not ionized here. They are inside the complex only. And bromine, which is the secondary valency, it is ionized here, which means an aqueous solution of this complex will give the taste for bromide ion, but this will not give the taste for ammonia or chloride ion, or this will not give the taste for cobalt 3 plus ion also. That is the meaning for non-ionizable. Okay, so this is cobalt 3 plus, but this is a complex which will not give the taste for cobalt 3 plus ion or ammonia or chloride ion. Okay, this is about the primary and the secondary valency. Let me go to the third postulate, fourth postulate, which is again about the secondary and the primary valency. The primary valency corresponds to the oxidation number of the central metal, while the secondary valency corresponds to the coordination number of the central metal. This is the fourth postulate. Here one example is given. Ammonia and Cl are secondary valency. How many ammonia molecules are acting as ligand? In fact, secondary valencies are the ligands. Okay, so in this case, ammonia and the Cl, ammonia and the Cl, they are primary secondary valency. Okay, Cl and ammonia are secondary valency. How many ammonia? 5. How many chloride ion? 1. 1 plus 5, 6. So coordination number of iron in this complex will be 6. Coordination number will be 6. Okay, and sulfate ion has a charge of -2. So the complex will have a charge of +2. So if we calculate oxidation number of iron here, which I assume as x, plus ammonia has a charge of 0, x plus 0, chloride has a charge of -1, and this must be equated to the charge of the complex, that is +2. From here, value of x comes out to be +3, which is the oxidation number of the central metal. This is the oxidation number of iron. This can be calculated only if we know the second primary valency, that is sulfate ion. Okay, so primary valency corresponds to the oxidation number of the central metal, and secondary valency corresponds to the coordination number of the central metal. Okay, I hope this is clear. And the fifth postulate is about the secondary valency. The secondary valencies surround the central metal in a fixed geometry, which means the statement can be written like this also. The geometry of the complex, it can be written like this also. Geometry of the complex is decided by the secondary valency. Let me give example here. In this case, I am giving an example of iron, ammonia, 5Cl, and sulfate. The same example which I have mentioned above. Here 5 ammonia molecules, these are of secondary valency. This Cl is also secondary valency. So the 5 ammonia molecules and the Cl, they surround, the central metal is surrounded by these secondary valencies, 6 secondary valencies, in a fixed geometry. This geometry is octahedral. Okay, in an octahedral geometry, the secondary valencies surround the central metal, right? Another example is this one. It is a complex of nickel, in which 4 carbonyl molecules acts as the secondary valency, means ligand. So in this complex, nickel is surrounded by the 4 carbon monoxide molecule in the trihedral geometry. And if I take this example of platinum, in which 2 NH3 molecule and a 2 Cl molecule, this complex is a square planar complex, which means platinum is surrounded by the 4 secondary valencies. It can be in 2 fashion. This is the 2 Cl and the 2 ammonia molecules, they surround the central metal platinum in square planar geometry. This is in fact a cis fashion, and it can be in the trans fashion also. This 2 Cl can be in this position and in this position, and the ammonia will be here and here. That will be a trans isomer. So these are the postulates of Werner's coordination theory. In the next video, I'm going to explain about bonding in coordination compound. that will be explained in the next video. For today, let me complete this video. And before completing this video, a request to all of you: if you are new to the channel, please like this channel and subscribe to the channel. Also like this video and share it to your friends. Thank you.